on page 18, we have section 131, which is titled Angle Pair Relationships, and we are going to answer the question, what is the relationship? So today's lesson goes from page 18 to page 20. We're going to read page 20 first. We have question 168, which is titled Angle Pair Relationships. When working with diagrams in this course, you can assume that lines and segments that appear straight are straight, and you can rely on the geometric markings in a diagram. Also, you can assume that figures lie in the same plane, that is, the same flat surface. However, you should assume diagrams in this course are not drawn to scale. That means that you will not determine unknown angle measures in a diagram by using a protractor, but rather by using geometric relationships. Certain angle pairs relationships come up often enough in geometry that they have special names. Part A says two angles whose measure have a sum of 90 degrees are called complementary angles. And then, does your guys' have a little angle mark right here or a little box? It has a box? Okay. Each of those little boxes are supposed to be little angle marks like this, because they just didn't print correctly. Okay, so angle ABD is a right angle in the diagram at right, and angle ABC and angle CBD are complementary. If the measure of angle CBD is 76 degrees, what is the measure of angle ABC? Show how you got your answer. Okay, so they just tell us complementary angles have a sum, meaning they should add up to 90 degrees, but they tell us one of them. So actually, instead of adding, which is what it tells us the sum is to do, we do the opposite operation, which is to subtract. So we're going to start with the 90 that we know they should be. We subtract the one that we know, and we get the other one. Okay? So even though it says sum, sometimes you have to do the opposite to get that, the one that's missing. Okay? Part B says, if the sum of the measures of two angles is 180 degrees, they are called supplementary angles. In the diagram at right, angle LMN is a straight angle. The pair of adjacent angles, angle LMP and angle PMN, is a straight angle pair or a linear pair. If the measure of angle LMP is 60 degrees, what is the measure of angle PMN? Okay, so this one says their sum is 180. Instead of adding, we're going to what? Subtract. So we start with the 180 that they should be together. We subtract the one that we know. So the LMP, notice it's the smaller one over here on the left. We want this bigger one over here on the right, PMN. So we subtract 62, punch it in your calculator if you can't do that in your head, and you should get 118. All right, let's see one more definition. Part C says, when two lines intersect, the angles that lie on the opposite sides of the intersection point are called vertical angles. For example, the diagram at right has angle AED and angle CEB. So let's mark with our pencil where angle AED is at. So if you tap A, you tap E, you tap D, there should be a little X right there. Go ahead and draw an arc. And we're going to tap out CEB. So here's C, here's E, here's B. So we're going to draw an arc. Angle AED and angle CEB are a pair of vertical angles. We also have another pair of vertical angles that are opposite from each other, right? So angle AEC right here, I'm going to mark with a different color. And angle DEB, I'm going to mark with that same other color. So these two are vertical angles, and these two are vertical angles. they're also congruent to each other. All right, question D says, using the diagram at right, determine the measure of angle AEC, DEB, and angle CEB if x is equal to 23. Okay? So if we know that they are supplementary, meaning they make a straight line, they should add up back in part B to 180. So we start with our 180 that we know, and we do the opposite operation. We're going to subtract the 23, punch it into your calculator. You should get 157 degrees. So if angle AEC is 157 degrees, then angle DEB is also 157 degrees. Okay, they have the same measurement. What is angle CEB? Is it 157 or is it 23? 23. It's clearly the smaller one, right? Okay, good job. All right, jumping down to the bottom. Question 169 69 says, when angles have equal measure, they are referred to as congruent. Highlight the word congruent. If you don't have a highlighter, circle it with your pencil. Using your work from part D for problem 68, which pairs of angles are congruent and what other relationship do these angle pairs have? Okay, so part D. This one, right? Okay, so angle AED is going to be congruent to BEC. They're vertical and also congruent. Oh, I'm trying to point them out. And then the two pink ones, angle AEC and angle BED, are vertical angles to each other. Okay? So they're congruent and they're vertical. Congruent and they're vertical. And I think we write that down in bottom B. Yes, part B. Based on your observations from part A, write a conjecture. Remember that a conjecture is a statement based on incomplete evidence that is unproven. We're going to make a conjecture that all vertical angles are congruent. As you're going to need a piece of tracing paper. It says to give one per group, but I just gave you each one. Okay, so it says proof of the vertical angles theorem. When Jacob answered part B of problem 169, he wrote the conjecture vertical angles are congruent. Do you think Jacob's vertical angles conjecture holds for any pair of vertical angles? Be prepared to convince the rest of the class. So you're going to write down, yes, I think it's always going to be true, or no, I don't think it will be true every single time. So pick one or the other. Jacob's explanation includes the diagram showing intersecting lines. He wrote that A plus B equals 180 and A plus C equals 180. Are these statements true? So you're going to say yes or no. Why do you think so? Then for part C, you're going to answer the question, how can you use Jacob's statement in part B to prove that vertical angles are always congruent? Okay. Once a conjecture is proven to be true, it is referred to as a theorem. Since you have proven that vertical angles are always congruent, you're going to, are always congruent. Part C, you have now established the conjecture to be a theorem. So you can use it in the future to prove it again. All right. So what are you going to do? You're going to take your piece of tracing paper. You're going to put it over the top of the intersecting lines and trace the whole thing. Trace both lines completely all the way to the end and trace the A, the B, and the C. And then you're going to turn it and see what happens. Conjecture is proven to be true. It is referred to as a theorem. Since you have proven that vertical angles are always congruent, you have now established the conjecture to be a theorem, so you can use it in the future without proving it again. Discuss with your team the difference between a conjecture and a theorem and write down your ideas about the difference. So when we're done going over the last problem, you guys are going to talk about and fill in question 70. Okay, so Mira said, I remember from last year that I can use a sequence of rigid transformation to show that angles are congruent. So I used a different way to show that vertical angles are congruent. I drew intersecting lines on my paper. If I copy the figure onto tracing paper, like we just did, I can transform it so that the traced angle is exactly on top of the opposite vertical angle. Sounds like what we just did. That means they are the same, right? Jacob found Mira's description confusing. I don't understand. What do you mean? What does transform it mean? Why are they the same angle? Can you help? So you're going to use the tracing paper to copy the figure. We already did it. And transform it to show that angle B and angle C are congruent. And then the last part, question 72, let me zoom in a little. Here it says, for each diagram below, identify an angle pair relationship and use the angle pair relationship to write and solve an equation. Then answer the question. The diagrams are not drawn to scale. So let's look at A first. A, we have, what is the measure of angle MNP? So if you take your finger and you tap out, here's M, here's N, here's P. Inside that angle there with the vertex at N is a 3x. So we want to know what that 3x is equal to. But we can see that this line right here is straight. Okay? When you have a straight line, it's called a linear pair, and the two angles together should be supplementary. Flip back over to page 18. On page 18, how many degrees should supplementary angles sum up to? 180, right? Everybody see that? So we're going to take the 7x and the 3x. We're going to add them together because that's the sum, and they should equal 180. So the 7x plus 3x equals 180. 7x plus 3x is 10x. So we have 10x equals 180. And then the inverse operation of multiplying by 10 is dividing by 10. So when we take the 10x and divide it by 10, we're just left with x. And when we take the 180 and divide it by 10, we're left with 18. So what this is saying is that x is equal to 18, but we have to take that 18 and plug it back in. They said they wanted angle MNP. So when MNP was our 3x, so we're going to take that 3, multiply it by the 18. I did it on my calculator. I got 54. Okay? If you take 7 and multiply it by 18, you're going to get a larger number, right? Then when you add those two together, you should get back to 180. All right? On the question B, it says, what is the measure of angle FGH? So here's F, here's G, here's H. And each of those two angles inside that angle pair has a congruent mark. Congruent means that they're equal. So we're going to put an equal sign between the two expressions. So the expression here is 4x minus 5, and the expression here is 3x plus 2. Notice that we have variables on both sides of the equal sign. When you have variables on both sides, you have to move them to one side or the other. It's easiest to find the smaller term with the variable, in this case the 3x, to subtract from both sides. So 4x minus 3x is 1x. This one cancels. And then we have x minus 5 equals 2. Add 5 to both sides and you get 7. And then they want you to plug it back in to FGH. Where's FGH? That one's this one. So right here for 3x plus 2. So 3 times 7 is 21. 21 plus 2 is 23. Okay. All right, so in your team, you're going to go back. You're going to answer question 70 together.